Hi everyone, Elon Musk just launched XAI GrokIII yesterday, and right after this conference he made it available for the Premium Plus users, and he was so generous that today he made it available to all free users. So literally it means everyone can access it. And I'm going to review this new model with the questions I normally used on thinking models, reasoning models. I'm going to show you all these questions I'm going to use today. Today's focus is on physics, and I chose the 3 questions. You may have a brief look. So 1F equals MA challenge, which is like Olympiad for American lower junior and secondary physics student. Okay, I selected this thinking model and pasted it here and to launch the question. So the thinking starts. Well, you can see the question and you can analyze it and work it out by yourself, but it's not today's main course, so I'm going to just pass it. Well, having thought about 36 seconds, it worked out, well, at least presented some thinking. And let's see, finally reached the right answer. Yes. Well, it's correct. The final answer is correct. Well, unfortunately, OpenAI failed this question. So the second question is actually at the start of the main course. So it's a famous 3-line switch question. I'm going to talk about it and analyze it for you before you see the answer. First, let's understand this challenge. Okay, the 3 light switches challenge. You are in a room with 3 light switches. Each switch controls one of the 3 light bulbs in an adjacent room. I suppose you can't see the light bulbs directly and you have to go into that room, but you can go into that room only once. How can you determine which switch controls which bulb? Well, I'll tell you that nearly all other models, thinking models, solve this problem. Okay, I think you can as well, but let me help you to comprehend this problem. So, well, our brain's not always trained for this kind of challenge. So let me explain. There are 3 switches and there are 3 bulbs. The 3 bulbs are in the next room and they're not labeled. You don't know which switch controls which light bulb. And now you're going to figure out, right, by going into the room only once. So this is very much like we have 3 switches here and 3 light bulbs, and the cables are intertwined together. We can't figure out whether simply by looking at it. So we have to tell only 2 bulbs and 2 switches intertwined together, or when the 2 bulbs are in the next room, which you can't see directly. This challenge is easy, right? What I should do is simply switch one and switch one on and the other off. And then I move on to the next room and we can discover which bulb is controlled by which switch. So for example, A bulb is controlled by B switch, which is easy to tell, right? So this is a binary problem. So the machine is very good in binary problems. Now we have 3 bulbs, not 2 bulbs. So if I switch on one of them, well, we can at least tell which, well, say switch C controls light bulb A, right? But we still have 2 bulbs left. We don't know which switch in the remaining 2 switches on the remaining unlit bulb, right? So that's the challenge, okay? You can pause. You might have a few minutes or a while, maybe 1 hour, maybe take a walk to work it out, okay? And then you can resume this. Okay, some of you guys might have the right solutions. I'm going to talk about it. Okay, I think switching on is a measure everyone could come up with, and if you, well, all I did is first I thought this was a logical problem, and then, okay, so it's kind of challenging to find another signal to eliminate this level of uncertainty, right? In the vernacular of these IT guys, we call it entropy. Well, information entropy. You need to cut it down. So then I realized this is a physics. I realized this was a physics question. So the solution just presented itself easy. So first we switched one of them, say switch C, right? For a while, maybe for 1 minute or 2 or 3 or 4 or 10 minutes if you like, and then we switched off, and then another one like switch B, and we're sure that one of the bulbs is lit, and then we go into the adjacent room. We can tell that bulb B is controlled by switch B, and then there are 2 of them not lit, right? So what do? We carefully touch both unlit bulb, and one of them is going to be hot, right? So we can feel it. So that's how we can tell, differentiate to the remaining 2. So I think we can just feel that light bulb A is hot, and we can tell that switch C actually controls. Okay, now let's take a look at the solution presented by GrokIII. So after a thought of 36 seconds, so let's see the outlines. All right, first label, good. Second, manipulate, great. Manipulate switches, what we analyzed. So but what's important is this manipulation. So first, to turn on switch A and leave it on for a few minutes, maybe take a walk for 5 minutes and come back. And this allows the bulb, it controls to heat up. After the waiting period, turn off switch A and immediately turn on switch B. And leave switch C off. This is important. Okay, so we use 2 kinds of signals: visual signals and thermal signals to determine. So then step number 3, we walk into the adjacent room and we find that 1 bulb is lit and 2 are off. However, one of them is warm, the other is cool, the temperature room. So that warm bulb was controlled by the first switch A. And the remaining one, I mean the bulb off and cool, corresponds to C. So this is very much what we did. So we can deduce that the bulb that's on is controlled by switch B because we last left it on. So next one, the bulb that's off but warm was controlled by switch A, the one we first switched on. And then the one that has nothing, I mean off and cool, is controlled by C. So every reasoning model, actually, I tested namely Gemini, Le Chat by Europe, from Europe, 3 mini high, and DeepSeek, all 4 reasoning models got it right. And here, yes, you can get right, but the question is, these models are trained with the known information found on the internet, right? So is that a possibility that all these models just memorize the solution, because this is a classic challenge, and it's public, it's available online. And we know that we have just consumed just very close to consuming all of the information on the internet, which means the pre-training era is over. Okay, so the question remains, do these models just memorize the solution? So what do we do? That's why I actually gave a variation to this classic problem. I checked last time, no one just amends this question this way, at least not on the internet. So that means this challenge is new to all of the models. I suppose it's still new to GrokIII. So I'm going to pass it to Grok, but this time I'm going to server the link. So let me open up another dialog. So thinking mode,